Welcome to World Tube, where we dive deep into fascinating stories from around the world and beyond, and today, we're embarking on an incredible journey through the cosmos to uncover the mysteries of space, the final frontier that has sparked humanity's imagination and curiosity for countless generations. From the ancient civilizations who mapped the stars and crafted myths about constellations, to modern scientists using powerful telescopes and cutting-edge technology to peer billions of light years into the past, our quest to understand the universe is as old as humanity itself. In this video, we'll explore the awe-inspiring origins of the universe with the Big Bang, the breathtaking beauty of galaxies, stars, and black holes, and the ongoing search for alien life on distant exoplanets. As we journey through time and space, we'll also discuss humanity's bold and ambitious plans to colonize other planets, like Mars, and the role future technology will play in ensuring our survival as a species among the stars. So, join us as we unravel the cosmic wonders that define our existence and envision an extraordinary future beyond Earth. The birth of the universe. Let's begin with the moment that started it all, the Big Bang. Around 13.8 billion years ago, the universe originated from a single point of infinite density and temperature singularity before expanding in an event we call the Big Bang. Contrary to what some may imagine, this wasn't an explosion in space, but rather an expansion of space itself, rapidly stretching the fabric of the universe in all directions. In just fractions of a second, the universe underwent a period of incredible inflation, growing from smaller than an atom to the size of a galaxy. As the universe expanded, it began to cool, allowing the formation of the first particles, quarks, and electrons, which combined to form protons and neutrons. Over time, these particles came together to create the simplest elements, hydrogen and helium. Roughly 380,000 years after the Big Bang, the universe had cooled enough for these atoms to form, releasing photons and filling the cosmos with light. This event, known as recombination, is what we observe today as the cosmic microwave background radiation, a faint glow that provides a snapshot of the infant universe. Over millions of years, gravity took over, pulling clouds of hydrogen and helium together to form the first stars. These stars illuminated the darkness, marking the universe's next major phase, the era of reionization. Inside these stars, nuclear fusion created heavier elements like carbon, oxygen, and iron, which would later form the building blocks for planets and life. When massive stars exploded as supernovae, they scattered these elements across the universe, seeding the formation of new stars and planets, including our solar system. But while visible matter galaxies, stars, and planets is the most familiar aspect of the universe, it makes up only about 5% of its total composition. The rest is dominated by two mysterious entities, dark matter and dark energy. Dark matter, which accounts for roughly 27% of the universe, is an invisible substance that doesn't emit or absorb light but exerts a gravitational pull. It acts as the glue holding galaxies together, preventing them from flying apart as they rotate. Without dark matter, the structures of the universe as we know them couldn't exist. Even more enigmatic is dark energy, making up about 68% of the universe. Scientists believe dark energy is responsible for the accelerated expansion of the universe, pushing galaxies farther and farther apart. Imagine inflating a balloon, but instead of slowing down, the expansion speeds up, a phenomenon discovered in the late 1990s that revolutionized our understanding of the cosmos. Understanding these forces is crucial to piecing together the story of the universe. What is dark matter made of? Why is dark energy causing the universe to expand faster? And what does this mean for the future of the cosmos? Scientists are searching for answers using powerful telescopes, particle accelerators, and experiments that delve into the quantum realm. From the fiery birth of the universe to the mysterious forces shaping its evolution, this cosmic journey reveals the intricate and awe-inspiring tapestry of existence. It's a story still being written, with discoveries yet to come that may forever change how we see our place in the universe. Our solar system, around 4.6 billion years ago, a massive cloud of gas and dust in a region of the Milky Way galaxy began to collapse under its own gravity. At its center, intense pressure and heat ignited nuclear fusion, giving birth to our sun, a glowing ball of plasma that would become the heart of the solar system. Surrounding the young sun, leftover gas and dust formed a rotating protoplanetary disk where tiny particles collided and clumped together to form planetesimals, the building blocks of planets. Over millions of years, these planetesimals merged, creating the 8 planets and countless other celestial objects we know today. Let's take a brief tour of the solar system and explore the unique characteristics of its members. 1. Mercury. As the closest planet to the Sun, Mercury experiences extreme temperature fluctuations ranging from scorching heat during the day to freezing cold at night. Its surface is heavily cratered, resembling our Moon, and it has almost no atmosphere to retain heat. 2. Venus, often called Earth's twin because of its similar size and composition, Venus is anything but hospitable. Its thick atmosphere of carbon dioxide traps heat through a runaway greenhouse effect, making it the hottest planet in the solar system, with surface temperatures hot enough to melt lead. 3. Earth, our home planet, is unique in its ability to support life, thanks to its liquid water, breathable atmosphere, and protective magnetic field. It's the only planet where conditions are just right for a diverse range of ecosystems to thrive. 4. Mars. Known as the red planet due to its iron-rich surface, Mars is often considered Earth's sibling. Its thin atmosphere, cold temperatures, and evidence of ancient riverbeds make it a prime target for the search for past or present life. Future missions aim to establish a human presence on its dusty surface. 5. Jupiter. The largest planet in the solar system, Jupiter is a gas giant made mostly of hydrogen and helium. Its iconic Great Red Spot is a massive storm that has been raging for centuries. Jupiter's powerful gravity also protects the inner planets by capturing or deflecting comets and asteroids. 6. Saturn. Famous for its stunning ring system, Saturn is another gas giant. Its rings are made of countless ice and rock particles, and it hosts dozens of moons, including Titan, which has a thick atmosphere and liquid methane lakes. 7. Uranus. This ice giant has a pale blue-green color due to methane in its atmosphere and is unique for its extreme tilt, which causes it to spin on its side. Its unusual orientation likely resulted from a massive collision early in its history. 8. Neptune. The farthest planet from the Sun, Neptune is known for its deep blue color, fierce winds, and storms. Like Uranus, it is an ice giant with a composition dominated by water, ammonia, and methane. Beyond the planets, the solar system is filled with fascinating objects. The asteroid belt, located between Mars and Jupiter, the asteroid belt is a region of rocky debris left over from the solar system's formation. The largest object here is Ceres, a dwarf planet that might have water beneath its surface. Dwarf planets, Pluto, once considered the 9th planet, is now classified as a dwarf planet. Along with others like Eris, Haumea, and Makemake, these icy worlds inhabit the Kuiper Belt, a region beyond Neptune filled with small, frozen bodies. The Oort cloud, farther out still, the Oort cloud is a theoretical sphere of icy objects that surrounds the solar system. It's thought to be the source of long-period comets, which take thousands of years to orbit the Sun. Our solar system is a dynamic and diverse neighborhood, full of wonders that continue to amaze and inspire us. Each planet, moon, and region offers clues about the history of our cosmic backyard and the processes that shaped it. From the fiery sun to the icy edges of the Oort cloud, the solar system is a testament to the beauty and complexity of the universe. The wonders of space. As we journey deeper into the cosmos, we encounter some of the most fascinating and enigmatic phenomena in the universe. These celestial objects challenge our understanding of physics and offer clues about the extreme conditions that exist in space. Let's explore some of these wonders, including black holes, neutron stars, pulsars, and exoplanets, as well as the search for habitable worlds beyond our solar system. Black holes, one of the most mind-boggling and mysterious objects in space, is the black hole. These are regions in space where gravity is so intense that nothing, not even light, can escape once it crosses the event horizon, the point of no return. Black holes form when massive stars run out of fuel and collapse under their own gravity at the end of their life cycles. The core of the star becomes incredibly dense, creating a singularity, a point of infinite density with no volume. Despite their name, black holes can be detected by the effect they have on their surroundings. When a black hole pulls in gas and dust from nearby stars, the material forms a hot, glowing accretion disk as it spirals in. This process can release immense amounts of energy detectable by telescopes. Supermassive black holes, which can have masses millions or even billions of times that of the Sun, are thought to reside at the centers of most galaxies, including our own Milky Way. The study of black holes has revolutionized our understanding of space, time, and gravity, but many of their deepest secrets remain locked away, leaving scientists to explore their mysteries. Neutron stars and pulsars. Another fascinating result of stellar evolution is the neutron star. These dense remnants form after a massive star explodes in a supernova, colossal stellar explosion that marks the end of a star's life. What remains is a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. The core of the star is primarily made up of neutrons packed tightly together, and its gravitational field is incredibly strong. Some neutron stars emit regular beams of electromagnetic radiation, which sweep across the sky like a lighthouse beacon. These rotating neutron stars are known as pulsars, named after the pulsing signals they emit. The discovery of pulsars in the 1960s was groundbreaking, as it provided a new way to study the universe and test our theories of matter and gravity under extreme conditions. Pulsars are also used as natural cosmic clocks, helping scientists measure the fabric of spacetime itself. Supernovae are among the most violent and spectacular events in the universe. These stellar explosions mark the death of massive stars and release an enormous amount of energy equivalent to the Sun's entire lifetime of energy output, all in a few seconds. When a star explodes as a supernova, it can outshine an entire galaxy for a brief period, and the shockwave from the explosion can trigger the formation of new stars. The remnants of the supernova, including heavier elements like gold and uranium, are scattered into space, enriching the interstellar medium and fueling the creation of new stars and planets. Supernovae are also crucial in the study of the universe's expansion. Certain types of supernovae, called Typia supernovae, have been used as standard candles to measure cosmic distances, helping astronomers discover that the universe is expanding at an accelerating rate thanks to the mysterious force of dark energy. Exoplanets and the search for habitable worlds. Beyond our solar system, scientists have discovered thousands of exoplanets, planets that orbit stars other than our Sun. These distant worlds vary widely in size, composition, and distance from their parent stars. Some are gas giants like Jupiter, while others are rocky planets similar to Earth. The discovery of exoplanets has opened up new frontiers in the search for extraterrestrial life, as scientists focus on finding planets that might harbor conditions suitable for life. The key to finding a habitable exoplanet lies in the concept of the habitable zone, sometimes referred to as the Goldilocks zone, a region around a star where conditions are just right for liquid water to exist on a planet's surface. Planets in this zone are prime candidates for study, and space telescopes like the Kepler Space Telescope and the James Webb Space Telescope are at the forefront of this search. In recent years, astronomers have identified a number of Earth-sized exoplanets within their star's habitable zone, some of which may even have water and atmospheres conducive to life. The discovery of such planets raises tantalizing possibilities. Could life exist elsewhere in the universe? Could we one day travel to these distant worlds? While the search for extraterrestrial life is still in its early stages, every new exoplanet discovery brings us closer to answering these fundamental questions. The search for life beyond our solar system. As we look farther into the cosmos, the question of life beyond Earth remains one of humanity's greatest quests. Whether life exists on planets orbiting distant stars or in the clouds of Venus or the subsurface oceans of moons like Europa and Enceladus, scientists are exploring every possibility. In addition to studying exoplanets, missions to Mars, Europa, and Enceladus seek to find signs of life, past or present. The search for alien life is expanding into new realms, from the hunt for biosignatures on exoplanets to the search for technosignatures, evidence of technologically advanced civilizations. Radio telescopes listen for signals from distant stars, while space probes continue to explore the distant reaches of our solar system. While we haven't yet found definitive proof of life beyond Earth, the search continues, fueled by the hope that we are not alone in this vast and mysterious universe. Conclusion: the wonders of space, from black holes and neutron stars to exoplanets and the ongoing search for life, remind us of the infinite possibilities that lie beyond our understanding. These phenomena challenge our perceptions of the universe and push the boundaries of scientific exploration. As our technology advances and our knowledge deepens, we may one day unlock the secrets of the cosmos, revealing answers to the most profound questions about the nature of existence and our place in the universe. The journey is far from over, and the wonders of space will continue to captivate and inspire generations to come.
The space race in modern exploration. The exploration of space is one of humanity's most ambitious endeavors, and its history is marked by fierce competition, groundbreaking discoveries, and technological leaps. From the early days of the space race to the modern age of space exploration, the journey has been one of rivalry, collaboration, and innovation. Let's take a closer look at the history of the space race, the modern advancements in space exploration, and the role of AI and robotics in pushing the boundaries of what we can achieve beyond Earth. The space race. USA versus USSR. The space race between the United States, the Soviet Union, which began in the late 1950s, was one of the most significant geopolitical struggles of the Cold War. Both nations sought to demonstrate technological and ideological superiority by reaching new frontiers in space exploration. The competition was fierce, with each side trying to outdo the other in a series of firsts in space. It all began in 1957 when the Soviet Union launched Sputnik 1, the first artificial satellite, into space. This event marked the beginning of the space race, and it sent shockwaves through the world, especially in the United States. In response, the US quickly accelerated its own space program, establishing NASA in 1958. The space race reached its peak in 1961 when Yuri Gagarin, a Soviet cosmonaut, became the first human to orbit Earth aboard Vostok 1. This achievement left the US scrambling to catch up, culminating in President John F. Kennedy's ambitious challenge in 1961 to land a man on the moon by the end of the decade. In 1969, the United States achieved this goal when Apollo 11, led by astronauts Neil Armstrong and Buzz Aldrin, successfully landed on the moon. Armstrong's iconic words, "That's one small step for man, one giant leap for mankind," marked a turning point in the space race and solidified the US as the victor. The moon landing was followed by 5 additional Apollo missions, each expanding our knowledge of the moon and laying the groundwork for future space exploration. While the space race was characterized by rivalry, it also led to a number of scientific and technological breakthroughs. Both the US and the Soviet Union developed technologies that would later form the foundation for modern space exploration, such as satellite communication, space station technology, and the development of rocketry. Modern advancements in space exploration. While the space race may have ended in the 1970s, space exploration didn't slow down. In fact, the space industry has entered a new era of innovation, with private companies and international collaborations leading the way. Let's take a look at some of the major advancements in modern space exploration.
The role of AI and robotics in space exploration. In addition to advancements in spacecraft and telescopes, artificial intelligence, AI, and robotics are playing an increasingly important role in space exploration. These technologies help manage the complexity of space missions, analyze vast amounts of data, and perform tasks that are too dangerous or difficult for human astronauts. AI is used in space to automate operations, optimize flight paths, and even assist in the discovery of new exoplanets. AI algorithms can sift through massive datasets from telescopes like the JWST, identifying potential candidates for further study. AI also powers autonomous systems on spacecraft, allowing them to make decisions on their own, such as navigating through space, adjusting for obstacles, or managing onboard resources. Robotics has revolutionized space exploration with robotic rovers like Curiosity and Perseverance on Mars, as well as rovers and landers on the Moon. These robots can explore alien landscapes, collect samples, and send back data that would be impossible for humans to gather without the risk and cost of manned missions. NASA's Robonaut and the Canadarm robotic arm used on the ISS also show how robots can assist astronauts in space, performing tasks with precision and reliability. AI and robotics are also being used in the development of space habitats and life support systems. These technologies help manage resources, ensure astronaut safety, and perform repairs or maintenance on spacecraft and space stations, all of which are essential for long-term missions beyond Earth's orbit. Conclusion: from the fierce competition of the space race to the exciting achievements of SpaceX, NASA, and other players, space exploration has come a long way. Today, humanity stands on the precipice of a new era of exploration, with missions to the Moon, Mars, and beyond promising to reveal more about the cosmos and our place within it. The role of AI and robotics will only continue to grow, enabling us to explore more distant worlds, solve complex challenges, and push the boundaries of what's possible in space exploration. As we continue our journey into the stars, the possibilities are endless, and the future of space exploration looks brighter than ever. The future of humanity in space, 25 to 30 minutes. As we look toward the future, the possibilities for humanity's presence beyond Earth are both exhilarating and daunting. The dream of settling on other planets, building permanent habitats in space, and even traveling to distant stars has moved from the realm of science fiction to the realm of achievable goals. Let's explore some of the key plans and ideas shaping humanity's future in space. Mars colonization, SpaceX, and NASA's plans. One of the most ambitious goals for humanity's future in space is the colonization of Mars. Both SpaceX and NASA are actively working on plans to make this vision a reality, though their approaches differ. SpaceX, under the leadership of Elon Musk, has set an ambitious goal of sending the first crewed mission to Mars as early as the 2020s, with the ultimate aim of establishing a self-sustaining colony on the Red Planet. The cornerstone of this plan is Starship, SpaceX's next-generation spacecraft, which is designed to carry large numbers of people and cargo to Mars. Musk envisions building a city on Mars with the infrastructure to support life, from habitats to power generation and even agriculture. For SpaceX, the goal isn't just to visit Mars, but to make humanity a multi-planetary species ensuring survival and prosperity by spreading beyond Earth. NASA's Artemis program is the first step toward Mars colonization. The goal is to return humans to the Moon, build a sustainable lunar base, and use the Moon as a stepping stone to Mars. NASA's plans for Mars include sending astronauts to the planet in the 2030s. This mission will focus on scientific exploration, testing new technologies, and studying the effects of long-duration space travel on human health, all of which are critical to the eventual goal of establishing a human presence on Mars. While both SpaceX and NASA have set ambitious timelines, Mars colonization is an incredibly complex challenge. It requires solutions to many problems, such as radiation exposure, life support systems, resource utilization, and the psychological and physiological effects of long-term space travel. Nonetheless, the progress made so far, particularly by SpaceX with reusable rockets and spacecraft, has brought the dream of Mars colonization closer to reality. Building space stations, O'Neill cylinders, and long-term living. In addition to planetary colonization, the concept of building space habitats has become a central idea for humanity's future in space. One fascinating proposal is the O'Neill cylinder, conceived by physicist Gerard K. O'Neill in the 1970s. These massive space stations would be cylindrical habitats that rotate to create artificial gravity. Inside, humans could live and work in a self-sustaining environment, complete with agriculture, manufacturing, and recreation. An O'Neill cylinder would be located in Lagrange points, regions in space where the gravitational forces of the Earth and the Moon or Earth and the Sun balance out, allowing for stable, long-term orbits. These space stations could house thousands of people and offer a variety of environments, from Earth-like cities to agricultural zones, all while remaining in space. Today, we're still far from building such large-scale habitats, but the technology is evolving. Projects like the International Space Station, ISS, are providing valuable insights into long-term living in space, from how to grow food in microgravity to how to deal with radiation exposure. The ISS is essentially a laboratory for space habitation, and lessons learned there could help humanity build more permanent, self-sustaining habitats in space. Other proposals include space hotels and research outposts, which could be the stepping stones toward larger, more permanent space habitats. In the long run, O'Neill cylinders and similar habitats could serve as places for scientific research, tourism, and even as stepping stones to colonizing other celestial bodies like Mars or the Moon. Interstellar travel, the next frontier. While colonizing Mars is an exciting prospect, humanity's ultimate goal may lie beyond our solar system. Interstellar travel, the idea of traveling to stars and planets outside our solar system, has long been a dream of scientists and visionaries. Although the technology needed for interstellar travel is far beyond our current capabilities, the concept has captured the imagination of many. One of the most talked about methods of interstellar travel is the breakthrough propulsion system that could one day allow us to travel at a significant fraction of the speed of light. Concepts like the warp drive popularized by Star Trek and solar sails are under theoretical consideration. Solar sails would use radiation pressure from stars to propel a spacecraft across vast distances, while a warp drive would theoretically bend spacetime itself, enabling faster-than-light travel. In reality, the challenges of interstellar travel are immense. The nearest star system, Alpha Centauri, is over for light years away, meaning it would take over for years to get there, even if we could travel at the speed of light. Current spacecraft, like NASA's Parker Solar Probe, travel at a fraction of that speed, and even the fastest proposed propulsion methods would take decades, if not centuries, to reach nearby stars. However, advancements in physics, materials science, and propulsion technologies could one day make interstellar travel a reality, though it may take centuries or even millennia to achieve. Preserving Earth, a balancing act as we look to the stars, it's important not to forget the planet we call home. The quest for space exploration must be balanced with the urgent need to protect and preserve Earth. Environmental challenges, from climate change to resource depletion, are growing threats to our survival, and as we explore other worlds, we must also focus on preserving the one we have. The idea of space colonization and exploration often goes hand in hand with the notion of escaping Earth's problems, but in reality, the sustainability of life beyond Earth will depend on the lessons we learn from managing our own planet. Technologies developed for space exploration, such as sustainable energy systems, recycling technologies, and closed-loop ecosystems, can be applied to solving Earth's environmental challenges. Similarly, the exploration of other planets can teach us about the delicate balance of life-supporting systems, informing how we better protect our own environment. Space exploration should not be seen as a replacement for caring for Earth, but rather as a complement to it. As we push the boundaries of space exploration, we must also work to ensure that Earth remains a vibrant, sustainable home for future generations. Conclusion: as we've seen, the journey from the origins of the universe to humanity's future in space is one of incredible discovery and unbounded potential. From the birth of stars and planets to the ambitious plans for Mars colonization, space is a canvas upon which humanity can paint its future. The stars are not just points of light in the sky. They represent infinite possibilities waiting for us to explore. Whether it's establishing a foothold on Mars, building space stations, or dreaming of interstellar travel, the future of humanity lies not only in the heavens but in our ability to dream big and act boldly. Our reach may extend to the stars, but the path forward will depend on the choices we make today and the courage we have to explore new frontiers. As we look to the future, remember, the journey into space is not just a technological challenge, but a testament to the spirit of human curiosity, innovation, and exploration. Let us continue to dream, to reach, and to venture boldly into the unknown. The stars are calling, and it is up to us to answer.